So let's see if we can evaluate the indefinite integral x over 2 times sine of 2x squared plus 2 dx. And try to pause the video and see if you can work through it on your own. So let's see what is going on here. So I have this x over 2, and then I have sine of 2x squared plus 2. Now if I were just taking the indefinite integral of sine of x, that is pretty straightforward. The indefinite integral of sine of x, well, we know that the derivative of cosine of x is equal to negative sine of x. So if I were to take the derivative of negative cosine of x, that's going to be positive sine of x. So this is just going to be negative cosine of x. And I could have made that even clearer. I could have put a negative here and then a negative here. And then you say, okay, well, look, the antiderivative of negative sine of x is just cosine of x. And then I have this negative out here, negative cosine of x. But that's not what I have here. I don't have sine of x. I have sine of 2x squared plus 2. But then I have this other thing with an x here. And so what your brain might be doing, or it's good once you get enough practice when your brain will start to do this, say, okay, well, this is interesting. This kind of looks like the derivative of this. If we were to call this, I'm tired of that orange. If we were to call, hey, why am I, this color changing is, if we were to call this f of x, if 2x squared plus 2 is f of x, 2x squared plus 2 is f of x, what is f prime of x? Well, then f prime of x is going to be 4x. And this thing right over here isn't exactly 4x, but we can make it. We can do a little rearranging, multiplying and dividing by a constant, so this becomes 4x. What if we were to multiply and divide by 4? So we multiply by 4 there, and then we divide by 4, and then we take it out of the integral sign. And even better, let's take this 2 out. So let's take the 1/2 out of here. So this is going to be 1/2. And so I could have rewritten the original integral as 1/2 times 1/4. So it's 1/8 times the integral of 4x times sine of 2x squared plus 2 dx. Well, now this is interesting, because if this is f of x, if this business right over here is f of x, so we're essentially taking sine of f of x, then this business right over here is f prime of x, which is a good signal to us that, hey, the reverse chain rule is applicable over here. We can rewrite this. We could also rewrite this as this is going to be equal to 1. We can rewrite this as the same thing as 1/8. I want to do the same colors. I'm using a new art program, and sometimes the color changing isn't as obvious as it should be. So 1/8 times the integral of f prime of x, f prime of x times sine of f of x, dx. Let me throw that f of x in there. So sine of f of x. And so when you view it this way, you say, hey, by the reverse chain rule, I have a function and I have its derivative here. So I can really just take the antiderivative with respect to this. This is essentially what we're doing in u substitution. You could do u substitution here. You could set u equaling this, and then du is going to be 4x dx. But now we're getting a little practice, starting to do it a little bit more in our heads. So what would this integral evaluate out to be? Well, this would be 1/8 times, well, if you take the antiderivative of sine of f of x with respect to f of x, well, we already saw that that's negative cosine of x. So this is going to be times negative cosine of f of x. Negative cosine of f of x. Negative cosine of f of x. Whoops, I want to put a blue there. And then, of course, you have your plus c. So what is this going to be? Well, instead of saying it in terms of f of x, we just say it in terms of 2x squared. This is going to be, or 2x squared plus 2. It's going to be 1/8 times, I have a function and I have its derivative, so I can really just integrate with respect to that function. So it's going to be times negative cosine of 2x squared plus 2, 2x squared plus 2. And then, of course, I have my, I keep switching to that color, I have my plus c. And of course, I could just take the negative out. It would be negative 1/8 cosine of this business, and then plus c. And we're done. We have just employed the reverse chain rule. We could have used u substitution, but hopefully we're getting a little bit of practice here. Hey, I'm seeing something here, and I'm seeing its derivative, so let me just integrate with respect to this thing, which is really what you would set u to be equal to. You're integrating with respect to the u, and you have your du here. This times this is du. So it's like integrating sine of u du. I encourage you, try to use u substitution here, and you'll see it's the exact same thing that we just did.